wouldn't mind, or somebody going on there and checking. All right. So I've done a problem like this before, but it was hand drawn, and I want to do it so it's a little bit cleaner. So what the problem is I've got a ball traveling down a ramp, and then it's going to be traveling horizontally across the ground. We're assuming no friction and no air resistance. And then it's going to come down, it's going to compress the spring, and then it's going to get launched right back up. So here's an animation showing what it's about, like showing how it goes. So it's going to compress it, and it's going to launch it right back up. So the problem that we're going to be dealing with is going to be when it comes down and compresses like that. So this would be the final state. So the initial state looks like this when it's at the top of the ramp. So we need to find the type of energy at each state. So this is going to be state 1. Now, the questions that you ask are, is there a height? And it doesn't matter what order these are in. And I'm just going to abbreviate here. So is there a height from the ground? Is it moving? In other words, does it have a velocity? And stretched, compressed, spring. All right, so those are the 3 questions you ask. And the height one is going to be dealing with U-grav. The moving one is going to be kinetic. And the last one is going to be U-elastic. Cool. So those are the 3 energies that these questions are dealing with. Was anybody able to check on YouTube to see if my audio was good? It should be. I don't want to make a video and then there not be audio. Somebody can check that real quick for me. All right. So dealing with state 1, the very first question, is there a height from the ground? So I look at my object. And it's on the wrong computer. So is there a height? It would help if I selected the line. So yes, there is a height from the ground. All right, thanks. Thanks for checking the audio. Okay. So it does have a height. So we do have gravitational. Now at the very first state, let me see if I can slow it down on the animation. So video, playback, slower. So if I go back to the video and I hit play, at the very initial point, like right when it starts, there's no velocity. Okay, so the object is not moving at state 1, so there is no kinetic. And at this point, at state 1, the spring has not been stretched or compressed, so there is no elastic. Cool. So the only energy that's present at state 1 would be gravitational potential. And I'm going to move this over here. So state 1, we have U grav. Cool. Now, at state 2, it's not going to be this figure, but it is going to be this one here. All right, so this is state 2. And if you guys are typing in the chat, I can't see it. Who just came in? That doesn't look like anybody new. Okay. So at state 2, the ball has reached the bottom of the ramp. Oh, let me get you Luigi. Okay. So it's reached the bottom of the ramp, and let's ask ourselves these questions again. So is there a height from the ground? No, because this bottom line right here, this is the ground. So it's traveling across the ground with no friction, no air resistance. So there is no height from the ground, so it can't fall. Is it moving? At this state, during this picture, this little snapshot, it is indeed moving. So we do have a velocity. And is the spring being compressed or stretched? At this point, no. So there's no elastic. Cool. So at state 2, we have kinetic. And then lastly, let's switch back over here. And then screenshot. So this is state 3. Hit cut instead of copy. Paste. So at this point, at state 3, we ask the same 3 questions. Is there a height? No. Now, this is where people get a little confused. So at state 3, this is the point where it has reached its maximum compression. So it has reached as far as it can go, and then it's on the verge of getting launched right back. So at this point, my velocity, as it's compressing the spring, it's getting slower and slower and slower, and then it stops, and then it changes direction, and then it goes that way. So at some instant where it changes direction, the inflection point where it goes traveling to the right and then it switches going to the left, the velocity has to reach 0 in order to switch directions. So that's where the state is at. So there is no velocity, and at this state, there is an object, or there is a spring that is being compressed. So there's going to be a U elastic at state 3. And I'll get rid of that screen clip. Okay. So, just as a reminder, the original length of the spring, so this length here, so this is called the rest length. Let me do a different color. So the length from here to here, this is the rest length. Okay. Now, when I go down to state 3, you'll notice that it is now compressed. So, curious if I can do this. Copy. Paste. And I don't know. Yeah. Let me find it on the other one. So there's a better picture. Here. Sorry, bear with me. I'm trying to accurately show you guys what I'm talking about. Yeah, here we go. All right. So, all right. So this is what I'm referring to. So the change in the length of the spring is going to be referred to as our delta x. So in this figure, this this kind of grayed out version, this is the rest length. So going from this line all the way to this wall, this grayed out spring, that's the rest length. And then this would be the compressed length of the spring. So if I switch back to over here. All right. Thank you, Natalie. I got you. So I switch back over here. I got you, Natalie. So this would be the rest length, and then this would be the compressed length. And the amount of distance that it changes while it's being compressed, that is my delta x. That's the amount that the spring is compressed. So if I switch back over here, that's what this delta x represents. So what we'll do tomorrow is we're going to pick up from this, and we're going to actually figure out what the velocity is and what the spring constant is in this problem. After I've given you guys some knowns. So the objective for this problem zoom 1. So the velocity at state 2 and the spring constant lowercase k. So that is going to be our objective, and then we're going to do that on the 22nd, or the 23rd, sorry, that's tomorrow. So we're going to do that on the 23rd. Cool. So what we did was we figured out from this video what the different types of energy were at the 3 different states that we were given. So just as a reminder, state 1 was here at the beginning when it's at the top of the ramp. State 2 was when it travels all the way down, it's at the bottom of the ramp and it's traveling horizontally. So there's only a velocity there, so we have kinetic. There's no height from the ground, and the spring has not been compressed or stretched. And then state 3 is when the spring has been fully compressed. My velocity at that point would be 0, so there's no kinetic, and of course it hasn't traveled vertically in either up or down, so there's no height from the ground. So gravitational at state 1, elastic at state, or sorry, kinetic at state 2, and then elastic at state 3. So that's what we've gotten through today. So does anybody have any questions? Did the animation help you guys? Okay. I'm hoping that it did, because I did spend a lot of time on Friday and Saturday trying to figure all that out, trying to make it look nice. I'm going to go ahead and end this